Good morning, students. Today we are going to continue with the quick revision Mathematics Standard 10. Here, Sonar Sir's Maths Class 10 Quick Revision Chapter number 2 Polynomial. Now, we'll discuss these all the 9 points in the chapter Polynomial. First is define polynomial. So what is the definition of polynomial? Exact concept of the polynomial. Then degree of a polynomial. Third point, we'll discuss types of the polynomial. Constant, linear, quadratic, cubic and biquadratic. After that, we'll discuss about the value of a polynomial. Fifth point, zeros of a polynomial, algebraic and geometric zeros. Sixth point, relationship between zeros and their coefficients. Seventh point, form new quadratic equation, formation of new quadratic equation. Then eighth number will discuss symmetric expression and their values. And the last and most important point we'll discuss the questions on the polynomial, most likely questions related to the chapter polynomial. So let's start with the first definition of polynomial. So what is the polynomial? Polynomial is an algebraic expression in which this a1, a2, dash dash up to an are the real number constant. So these are real number. What is this? X is a variable. And this with the exponent, that is power. Power is a positive integer. And this highest power is called degree of this polynomial. An algebraic expression in which a1, a2, dash dash up to an are the constant real number. We can say them coefficients. X is a variable. The index is a positive integer and the highest index is called degree of the polynomial. We'll discuss degree of the polynomial with the types of the polynomial. Now there are the first type, constant polynomial. Now what is constant polynomial? So constant polynomial, suppose this is 3. So thus f of x is equals to 3. Only constant number is there. We can write in standard form like this, 3x raised to 0. Because the degree of the polynomial is 0. So degree is 0. In this case, we say that this is a constant polynomial. Then let's move for the second, linear. So f of x equals to 3x plus 5. Now see, the degree means the highest power of the variable is 1. Degree is 1. Therefore, this is a linear polynomial. Then third one is quadratic polynomial. Suppose 3x square plus 5x plus 7. Here you can see the highest power is 2. Therefore, degree of this polynomial is 2. And this type of polynomial is called quadratic polynomial. Then cubic polynomial. What is the cubic polynomial? Again, we'll continue with the same example. Here, the highest power of the variable is 3. Therefore, degree of this polynomial is 3. Then the last one is biquadratic. Now biquadratic, here the biquadratic is x raised to 4 plus x cube plus x square plus x plus 3. So highest power of the variable is 4. So this type of equation is called biquadratic polynomial. So again, let's revise. What is a constant polynomial? A constant polynomial whose variable power is 0, that is degree is 0. Linear polynomial, degree is 1. Quadratic polynomial, degree is 2. Cubic polynomial, degree is 3. And biquadratic polynomial, degree is 4. In all these, only the degree and its coefficient must not be equal to 0. The coefficient of that degree must not be 0. The rest of the terms may be 0. Only if it is a degree 3, so this coefficient will not be 0. Rest of the terms may be 0. Now, let's see the value of a polynomial. What is the value of a polynomial? With example, we'll learn what is the value of a polynomial. Value of a polynomial is a real number of a variable. So value of a polynomial, let's take one example, 3x plus 5. For x is equals to 1, the value of this polynomial f of 1 is equal to 3 into 1 plus 5. We have to replace the variable with the real number. So 3 ones are 3 plus 5, so 8. So this is called value of a polynomial. So what is the value of a polynomial? It is a value when we replace the variable by a constant. That is called value of a polynomial. Now let's move for the zeros of a polynomial. Now what are the zeros of the polynomial? The value of the variable which satisfy the polynomial is called zero of the polynomial. For example, again take one example here. F of x is equals to 5x minus 3. Now, if we want to find value of this zero of this polynomial, then we have to equate with 0. For finding the zero of a polynomial, we equate the polynomial with 0. So 5x minus 3 equal to 0. So it becomes 5x equals to 3 and x is equals to 3 upon 5. So this term is called zero of the polynomial. Now let's cross check. If we replace x, if we replace this value of the x in the given polynomial, then it becomes 0. 5 will get cancelled. 3 minus 3 equals to 0. So value of the polynomial becomes 0 when x is equals to 3 upon 5. Therefore x equals to 3 upon 5 is called 0 of the polynomial. In another way, we can say that this is a factor also. That is x minus 3 upon 5 is a factor of the polynomial. Let's move with the relationship between the zeros and their coefficient. Now we'll discuss first zeros of a polynomial algebraically and geometrically. First we discuss value of polynomial, now zeros of polynomial. Now what is the algebraic and geometrical zeros of the polynomial? So algebraic, just we discussed that part is called algebraic zeros of a polynomial. Geometry, it is a graphical representation. Suppose a graphical xy coordinate system and this one is a curve, any curve which intersect the x-axis in 2 points. Suppose this is the first point, this is a second point. In that case, we say that this polynomial has 2 zeros. This is first one and this one is second one. So the point where the curve of the given equation intersect the x-axis, that point is called the zero of the polynomial geometrically. Now in the polynomial, we have to deal with linear, quadratic, cubic and biquadratic. So let's discuss the quadratic equation. You know the standard form of quadratic equation is ax square plus bx plus c. This is a quadratic form. This one is a quadratic equation. Now we have to discuss about the relationship between the zeros and their coefficient, and this is one of the important part of this chapter. Now just now we learned how to find the zeros. So when we don't know the zeros, we assume them alpha, beta. Now one more important trick is there. If the degree of the polynomial is 1, then zeros are also 1. Zeros are 1. If degree is 2, zeros are 2. If degree is 3, zeros are 3. Degree is biquadratic, zeros are 4. And so on. Whatever the degree, that much the zeros will be there for that particular polynomial. Here it is a quadratic equation. Degree is 2. Therefore, for this equation, there are 2 zeros and we assume the zeros as alpha and beta. So, what are the relationship between zeros of a polynomial? There is a separate derivation, but we need to discuss only the relationship. So, alpha, beta are the zeros of the polynomial, then sum of zeros, that is alpha plus beta is equal to minus b upon a. So what is the b? B is a coefficient of x. What is a? A is a coefficient of square term, x square. Now the next term is product of zeros. So what are the product? Product of zeros. So alpha into beta is equal to c upon a. So what is c? C is a constant of the quadratic polynomial and a is a coefficient of x square. So this is the relationship between the zeros and their coefficients. So alpha, beta are zeros and a, b and c are the coefficients. We discuss about the quadratic polynomial. In the same way, we'll discuss for the cubic also. So what are the relationship between the zeros and their coefficient for a cubic equation? The linear equation already we discussed, it is a simple one alpha, but quadratic and cubic, they have specific relationship. So let's discuss the cubic. For cubic equation, we'll write down first cubic equation. Here cubic polynomial and this one quadratic polynomial. So quadratic polynomial ax square plus bx plus c. For quadratic polynomial alpha plus beta is minus b upon a and alpha into beta c upon a. Why I am writing it again? Because it is easy to remember only quadratic. Cubic will get directly from the quadratic. Ax cube plus bx square plus cx plus d. Now this is a cubic polynomial. As this one is a cubic polynomial, as earlier we discussed, the degree of the polynomial is 3. Therefore, their zeros must be 3. So what are the zeros? Let's assume alpha, beta and gamma. alpha, beta and gamma are the zeros of this polynomial. Now what are the relationship? So sum of the zeros. So sum of the zeros, alpha plus beta plus gamma. If you write down in this order A, B, C, D and this quadratic polynomial A, B, C, then the formula is directly as this one, minus B upon A. Now product of the zeros. So product. So two products we have to take, alpha, beta, beta, gamma and alpha, gamma. And this product will be the second term, that is C upon A. And you have to remember only the third one. What is the third one? Alpha into beta into gamma, that is minus D upon A. The sequence is minus, plus, minus. So it is very easy to remember. Only you have to remember the relationship between the zeros of quadratic polynomial. What is the relationship between the zeros of quadratic polynomial? Their sum is minus b upon a and their product is c upon a. In the same way, if we represent the cubic polynomial, the sum of the zeros is minus b upon a, the product is c upon a. But product, two zeros we have to take at a time, alpha, beta, beta, gamma, alpha, gamma. And their sum of the product is second term, that is c upon a, and third term is product of these three zeros, alpha into beta into gamma, which one is minus d upon a. Again, if we forgot the sign, so just remember when it is minus, the next term is plus, again the third term is minus, it alter like this way. So let's move for the formation of new quadratic polynomial. So new quadratic polynomial, it is also called as family of the polynomial. So what is the quadratic polynomial? Suppose alpha and beta are zeros. Means new quadratic polynomial, alpha, beta are the zeros. The new quadratic polynomial, we write it down like this, constant k, here is a curly bracket, in x square minus in bracket sum of zeros into x plus product of zeros. We have to multiply the zeros. So in the form of alpha, beta, we write down like this, alpha square, alpha plus beta x plus alpha into beta. So you have to remember this form of the quadratic polynomial. When zeros, alpha and beta is given, either alpha and beta is given or sum and product of zeros is given, at that time we have to use this formula where k is a constant. K is a constant. This is called formation of new quadratic polynomial. Let's move the last topic of the definition, that is symmetric expression and values. Now what are the symmetric equations? Actually symmetric equation word is not used, but here symmetric equation means alpha square plus beta square, alpha cube plus beta cube, then alpha plus beta bracket square, then 1 upon alpha plus 1 upon beta, 1 upon alpha square, 1 upon beta square. These values are called symmetric expression and their values. So we'll discuss this with the example. Now the last topic, that is ninth one, is a most likely question. The definition part is over and now we'll discuss few questions related to the chapter polynomial. So polynomial chapter, mostly the questions asked are, if 1 0 is given, find the value of k. In this equation 1 0 is given to you. Two zeros are there for a quadratic polynomial. 1 0 is given, we have to find another 0. Then second time, find a quadratic polynomial whose sum and product of zeros is given. Just now we discussed the formation of new quadratic polynomial. The third one is alpha, beta are the zeros of a polynomial. Then find the value of 1 upon alpha, 1 upon beta, like this. Then find the value of k if 1 0 of a polynomial is given. Then one more time, that is for 3 marks, find the zeros and verify the relation between the polynomial. So we'll discuss one by one all the questions. So related to that, the first question, zeros of a polynomial x square plus px plus q, zeros of this polynomial are twice the zeros, and the another polynomial is 4x square minus 5x minus 6. So again, I read again the question. The zeros of the polynomial are twice the zeros of this given polynomial. Then value of the p. Then find the value of p. We have to find value of p only. There are two unknown terms, but he asks to find the value of p. Now twice word is given. Suppose this polynomial, the zeros are alpha and beta. So which polynomial is given? We consider their zeros as alpha and beta. And the zeros of this polynomial are twice the zeros of the given polynomial. We'll find the relationship between these zeros first. Alpha plus beta is equal to minus b upon a. Here we can see the coefficient of x minus b is 5. So minus 5. And the coefficient of x square, that is a, 4. So it becomes 5 upon 4. This is alpha plus beta. Now for this equation, alpha plus beta will be twice of alpha plus twice of beta, because it is given the zeros of this polynomial are twice the zeros of this polynomial. So here minus, what is the value of b? That is p, and a is 1. If we take 2 common, so it becomes alpha plus beta equals to minus p, and this alpha plus beta already we have 5 upon 4. So p is equals to minus 5 by 2. 2 ones are 2 twos are, and it becomes minus 5 upon 2. So this type of question may be there with the relation of the zeros. Let's discuss one more common question which is asked in the exam. If 1 0 of a quadratic polynomial k minus 1 in bracket x square plus kx plus 1 is minus 3. If 1 0 of the quadratic polynomial k minus 1 bracket x square plus kx plus 1 is minus 3, then the value of k, we have to find the value of k. The 1 0 is given. As this is a 0 of the given polynomial, it satisfies the equation. So we'll write this given polynomial as p of x is equals to k minus 1 plus kx plus 1. As minus 3 is a 0, so x is equals to minus 3. It satisfies the equation. So when value of x is minus 3, the equation becomes 0. We'll put this value here in place of x plus k into 0 plus 1, which is equal to 0. So this 0, x is equals to p of minus 3. So we're going to put x equals to minus 3 here. So everywhere we have to replace by minus 3. So minus 3 square is 9, k minus 1 into 9, minus 3k plus 1 equal to 0, 9k minus 9 minus 3k plus 1 equal to 0. So again this minus 9k minus 3k becomes 6k, minus 9 plus 1 becomes minus 8. So 6k equals to 8 and we'll get 8 equals to 6. So 2 4s are and 3s are, the value of the k is 4 upon 3. So in this way, one more question we solve, which most commonly asks, 1 0 is given to you and the unknown term like k, p to be find out. Let's move for the similar type of one more question. If alpha beta are the zeros of a polynomial, now alpha beta are zeros of a polynomial and the polynomial is 2x square minus 4x plus 5. Then find the value of, So which values? So first value is alpha square plus beta square. Then the second value is 1 upon alpha plus 1 upon beta. And the third value is alpha cube plus beta cube. And so on. We'll discuss these three values. Now just now we discussed symmetric expression values. These are called the symmetric expression values. So alpha beta are zeros of this quadratic polynomial and then we have to find the values of this one. This is the first one, second and third. So for this type of question, we'll find the relation between the zeros. So alpha plus beta. Now again, we already discussed the coefficient of x square is a, coefficient of x is b and last term is c. So alpha plus beta is minus b upon a. So what is the value of b? It is already minus. So minus and the value of a is plus. So we got the value of alpha plus beta as 2. Now we have to find their product also. So alpha into beta c upon a. C constant term is 5 and the coefficient of x square a is 2. So alpha into beta is 5 upon 2. We'll write down this aside for reference. Alpha plus beta is 2 and alpha into beta is 5 by 2. So let's find the first value, alpha square plus beta square. So we can find alpha square plus beta square by using this identity, alpha plus beta brackets. Always we have to make use of these two values, alpha plus beta and alpha into beta. So we have to find the conversion. Alpha plus beta bracket square is alpha square plus 2 alpha beta plus beta square. Here we'll get the value of alpha square plus beta square. Now which value already we are having? We have the value alpha beta and alpha plus beta. Now alpha plus beta is 2. Alpha square we don't know. 2 into alpha into beta we already have 5 by 2 plus this beta square. Now this 2 will get cancelled. The square of the 2 is 4 and this 5 on that side minus. So we'll get the first value, alpha square plus beta square. So what is the alpha square plus beta square? Alpha square plus beta square is minus 1. In the similar way, we have to find the second 1 upon alpha plus 1 upon beta. So for this, we have to cross multiply because always we are having only these two terms and we have to convert them into the given solution. So 1 upon alpha plus 1 upon beta. For this, we have to cross multiply, in short LCM. So cross multiply, this becomes beta into alpha upon alpha into beta. If we rearrange this term, because addition is commutative, so we can write alpha plus beta. Alright, alpha plus beta is 2. Alpha into beta is 5 upon 2. So we can write it 2 into 2 by 5. So the answer is 4 upon 5. So alpha 1 upon alpha plus 1 upon beta is 4 upon 5. Here we got the answer 4 upon 5. Let's move for the cubic. So cubic, alpha cube plus beta cube. Alpha cube plus beta cube. So we know the formula alpha plus beta bracket cube. So what is the formula for alpha plus beta bracket cube? So alpha cube plus 3 alpha beta in bracket alpha plus beta cube. Now you can see again we are having alpha plus beta. We have alpha into beta. We have alpha plus beta and we'll get alpha cube plus beta cube. So put alpha plus beta by 2. Then alpha cube, we don't have alpha cube, we'll keep it as it is. 3 alpha into beta is 5 upon 2. Alpha plus beta, again 2, plus this beta cube. Now 2 will get cancelled, 5 3s are 15, 4 minus 15. So here alpha cube plus beta cube. So 4 minus 15, here we got the answer alpha cube plus beta cube is minus 11. So in this way we find the solutions by using the relation between the zeros of the polynomial. Now one more question, and the most important for 3 marks question, that find the zeros and verify the relation between them. This is one of the important question mostly asked in exam. So we'll take one example of find the zeros and verify the relation between the zeros of the polynomial. So find the zeros of a quadratic polynomial and verify relation. We'll take one root example, root 3 x square minus 8x plus 4 root 3. This is a quadratic polynomial. We have to find zeros also and we have to verify relation also. So this type of question asks for 3 marks or more than 3 marks. Here we can find the zeros of this quadratic polynomial by 2 different ways. First one, by using the formula method. Quadratic equation in chapter quadratic equation will learn the formula method also. So you can make use of the formula method also and you can find the factors. The second one is middle term separation method, which is quite difficult for the student. We'll discuss that method here, that how to find the middle term separation method when root term is there, irrational number. So we have to multiply the coefficient of x square by constant term. So root 3 and this 4. So 4 into root 3 into root 3, it becomes 3 and 4 3s are 12. Here we want the addition as minus 8. So addition minus 8 as the middle term minus 8 and the product is 12. So we can consider 6 2s are 12 plus 6 plus 2 plus 12. But addition we need minus. In this case we have to take minus 6 minus 2. Now minus into minus becomes plus, and here both the condition will satisfy. Minus 6 minus 2 minus 8. But one more point that is to be remembered, that 6 must be replaced by root 3 into root 2. So let's write down the splitting term, middle term splitting. X square minus this 6x minus 2x plus 4 root 3. Now we'll take the common. Now here you can see the common term. Here root 3, here 6. So this 6 can be written as 2 into root 3 into root 3. This is the turning point of the question. Root 3 into root 3, 3 and 3 2s are 6. We'll take common. So root 3 and x taken common. So x minus 2 root 3. You can see here root 3, but here no term related to the root 3. We can take minus 2 common. So 2 2s are 4 and root 3. One more important point, whatever the bracket here, same bracket must appear here. And it appeared. So we'll take that common and we got the factors now. X minus 2 root 3 and root 3x minus 2. These are the factors, but we want to find zeros. So how to find zeros? For finding the zeros, we equate the equation with zeros. That is x minus 2 root 3 equal to 0. So x is equals to 2 root 3. This is our first zero. We'll consider it as a alpha 2 root 3. So we got the first zero, alpha 2 root 3, and we'll find the second zero. Second zero is root 3x minus 2 equal to 0. Root 3x equals to 2. So x equals to 2 upon root 3, which is our second zero, that is beta. So what is the beta? Beta is 2 upon root 3. So in this way we find the zeros of the given quadratic polynomial. We cover in this question two types. One, the root term is also there, and second, middle term separation method. You can find the zeros by using the formula method also. There is no restriction to find the zeros by particular method. It is not mentioned there. So we'll discuss now. When the zeros, we got the zeros now, and we have to verify the relation between the zeros. So suppose alpha, beta are the zeros of this quadratic polynomial. This term is A, this term is B, and this term is C. So sum of the zeros. So check it out, sum of zeros. So sum of zeros is minus B upon A. So what is minus? B is already minus 8, and A, the A term is root 3. So sum of the zeros is 8 upon root 3. Now let's check whether the sum of 0 is 8 upon root 3 or not. So alpha plus beta. So what is alpha? Alpha is 2 root 3. Plus beta, beta is 2 upon root 3. Again, there is nothing in denominator, 1 is there, cross multiply. So 2 root 3 into root 3 is 3 plus this 2 upon root 3. 3 2s are 6, 6 plus 2, 8 upon root 3. So sum of the zeros and the coefficients of the zeros, this is verified. So sum of zeros by actual adding the zeros is 8 by root 3, and by using the sum of the zeros relation between the coefficient, we got the same answer. So we can say here the relation between the zeros and their coefficients is verified. Now we'll discuss alpha into beta, the product of zeros. The product of zeros, again you know the formula for product of zeros is C upon A. So product of zeros. So product of zeros is C upon A. What is the constant value? This is 4 root 3. And what is the value of A? Root 3. Root 3 will get cancelled. So product of zeros is 4. So let's see product of zeros is 4 or not. So alpha into beta. What is alpha? Alpha is 2 root 3. What is beta? Beta is 2 upon root 3. This root 3 will get cancelled. 2 2s are 4. Then we can say the product of zeros and the relation between the coefficient is verified. So in this way we have to solve the questions related to the polynomial chapter. Thank you.